Get ready for an interstellar shock. Due to the fact that a group of scientists claim Betelgeuse, the mesmerizing Orion's bright red supergiant shoulder, has already exploded. Yep, you heard that right. We are not joking. Within the next 10 years or a few, its brilliant aftermath will last for decades, illuminating the night sky. But how did this happen? Should we allow scientists to make this claim? Should we be concerned? Could the James Webb Space Telescope capture the remnants of Betelgeuse today? We're diving deep into all the most recent information. One of the prominent stars in the sky above us in the northern hemisphere during winter is Betelgeuse, a red supergiant star. Is it among the handful of stars that shine brightly enough for us to actually see its reddish-orange color with the naked eye? Betelgeuse is usually the 10th brightest star in the night sky, but as you might already be aware, it has always been known to vary in brightness. Part of the reason for this is that Betelgeuse is not at all your typical star because of its massive size. If we were somehow able to replace Betelgeuse with our own little sun, it would cover the entire way to the asteroid belt and have a mass of an astounding 20 times the amount of the sun. It may come as a surprise, but Betelgeuse is actually quite young for a star, with an age estimated to be around 8 to 10 million years. In comparison, our own sun is much older, with an estimated age of about 4.6 billion years. This is due to the fact that supergiant stars like this burn rapidly through their nuclear fuel and go supernova relatively quickly on geological timescales. This also means they evolve rapidly, and Betelgeuse may actually have done that right before humanity's eyes. To understand how scientists came to the conclusion that Betelgeuse had already burst into flames, it's crucial to delve into the context. The tale begins around the 2nd century BC, when Chinese astronomers made a noteworthy observation that Betelgeuse exhibited a distinctive yellow hue. Advancing to the middle of the 2nd century AD, the Greek astronomer Ptolemy referred to it as orangish or ruddy, as it currently exists. Similarly, medieval observers in the Middle East witnessed a similar coloration. The question arises about how colors were named or perceived in the past, but in this case, there is an actual likelihood that Betelgeuse underwent a color change within a few centuries. It is plausible that Chinese astronomers observed Betelgeuse during its yellow supergiant phase. Over several centuries, it transitioned into the red supergiant phase. Given that humans by our nature are night sky watchers, you have to wonder how many people all over the world who were able to see the star noticed the change but left no records. After all, changes to a star like that probably came with all sorts of dimming and brightening events that aren't recorded. Imagine them pointing up to the night sky saying, "Hey, didn't that star used to be brighter?" And that is precisely what has been taking place, right? Betelgeuse is a variable star, but it seems to conform to some cyclic behavior. Starting in December 2019, Betelgeuse's brightness dipped by a huge amount, which was visibly noticeable to the naked eye. For those used to gazing at the star, it was not its normal self until early 2020. Over time, it recovered, and one theory was that some of these cycles had coincided, making for a particularly deep decrease in brightness. But the observations made by the Hubble Space Telescope indicated something rather peculiar. It appeared that Betelgeuse had expelled an immense amount of scorching material into space, forming an enormous dust cloud. This dust cloud, in turn, obscured a significant portion of the star's light when viewed from our perspective. The transformation was quite astonishing. Betelgeuse, once counted among the 10 brightest stars in the night sky, faded to a point where it ranked lower than the 20th brightest. It was truly baffling to observe its dimness in comparison to its neighboring star, Aldebaran, which currently holds the position in terms of brightness. Thankfully, Betelgeuse showed signs of improvement, but its unusual behavior did not cease. In fact, it is currently displaying a state even stranger than merely dimming. In recent months, Betelgeuse has undergone a dramatic increase in brightness that is greater than its normal luminosity by a staggering 50%. This puzzling situation is quite unsettling for a star that is known for its changes. The dimming events may be caused by dust or coinciding cycles, or maybe the star developed huge sunspots. However, a significant increase in brightness is a completely different thing. Although it could be related to the previous event when Betelgeuse expelled material in 2019, it probably resulted in a significant disruption in the star's plasma flow. The current behavior we observe could be considered an aftershock of that, ejection. But what lies behind this peculiar behavior surpassing the star's usual variability? One conservative hypothesis that has been extensively debated is that Betelgeuse is nearing the supernova phase. While conservative estimates still suggest that the star is approximately 100,000 years away from its supernova event, today we will provide evidence to question this idea and demonstrate that it already took place. So, what is the evidence? According to a groundbreaking recent scientific paper by Tohoku colleagues, linked to a Japanese university in the description, Betelgeuse has already undergone a supernova explosion, and we may be witnessing the consequences of this cosmic event spectacle within 10 years or a few decades from now. Yes, that's right. As amazing as it sounds, the last observed supernova in our galaxy was Kepler's supernova, which occurred way back in the 1600s. Through a thorough examination of Betelgeuse's variability patterns, the findings of the researchers include 4 distinct periodic changes occurring at intervals of approximately 2200, 420, and 230 days, during which the origin of the longest period remains unknown. It is speculated to be the fundamental period, with the shorter intervals that could potentially serve as overtones. The researchers propose a model that suggests Betelgeuse is in a late stage of carbon burning, implying that it might be getting close to a spectacular explosion, positioning it as a prominent candidate for the next expected supernova event within our Milky Way galaxy. When it comes to unraveling the mystery surrounding Betelgeuse, there is a puzzle for you to solve. There are some conflicting observations regarding the ejection of materials and the star's subsequent recovery. The general consensus leans towards a mass ejection event, something not entirely unheard of for various types of stars, although on a smaller scale compared to our own sun. But here's the twist. Supernovae are a real thing too. We actually witnessed one in a satellite galaxy of the Milky Way back in 1987. So while it's possible that our estimates for Betelgeuse's explosion timing could be off, don't go planning a vacation around it just yet. The tricky part is that Betelgeuse is currently tricky to observe. It has slipped behind the sun and won't be visible again until at least August. As a result, we're left in the dark about what this enigmatic star is up to at the moment. What we do know, however, is that it's bucking its usual trends by brightening. Now, here's something fascinating. Betelgeuse's immense size and relatively close proximity, approximately 650 light-years away, allow us to actually resolve a disk when observing it. Most stars are simply too far away, appearing as mere points of light. But with Betelgeuse, we have a rare opportunity to capture direct variations in its ability to produce light for photography. So we not only have a star that could likely explode, but also a lot of data to collect, including pictures, even though they may be a bit blurry. Let's imagine the scenario where Betelgeuse has, in fact, gone supernova. How would it look? First, things first, it's going to be a real spectacle, but don't worry, it's perfectly safe for us here on Earth. You see, Betelgeuse is, in fact, quite a ways away, so it won't cause any harm to our planet when it does go supernova. Though it won't be the brightest object in the sky, the moon will still significantly outshine it, and let's not forget about the sun. However, it would definitely cast its own shadows during the day and remain visible at night for about a year. Now here's the interesting component. The supernova would be visible for several years, gradually fading away. There might be a brief period where it regains some of its earlier splendor, but eventually it will continue to fade until the familiar shoulder star within the Orion constellation completely vanishes. While we won't be in any danger from the supernova, it could create some confusion for certain creatures. Some animals rely on moonlight for navigation, and with an additional bright light in the sky casting shadows, it might throw them off their game a bit. But that's not all. Astronomy itself would face some challenges. Observing the Earth's night sky in ancient times, the bright moonlight could be a little tricky. A very bright supernova would only complicate matters further. However, there would most likely be more, telescopes wishing to capture the supernova's glory than anything else, even if it means altering their observations. In addition, there would be some warning signs before the visible explosion, such as detecting neutrinos and gravitational waves from the star. But the big question is whether Betelgeuse has already gone supernova. Could we capture the remnant? For that, we have to wait for the James Webb Space Telescope to detect the supernova remnant. So how long could it take for Betelgeuse to go supernova? We're not absolutely sure, but it could occur as soon as next week, next year, or in 100,000 years. In cosmic terms, that's basically the same as right now. After all, it's simple to forget that the light we see from this star is actually centuries old, and 600 years ago we wouldn't even know about it. What do you think? Could Betelgeuse have already gone supernova, or is it just displaying some unusual variability? Let us know in the comments. Naturally, the James Webb Space Telescope is the ideal instrument for making these observations. We may not need to wait long before it solves the mystery once and for all. Throughout the endeavor to comprehend Betelgeuse's behavior and its implications for stellar evolution, a multifaceted approach is involved. Astronomy based on observation, combined historical analysis, and theoretical modeling. In this context, this star, well known for variation and enormous size, provides a unique opportunity for astronomers to study the life cycle of supergiant stars and the phenomena leading up to supernovae. Firstly, it's essential to grasp the significance of a supernova in the overall picture of cosmic evolution. A supernova is not merely a spectacular event. It's a critical process in the life cycle of stars. These explosions play an important part in spreading heavy elements throughout the galaxy. These components, forged in the cores of massive stars, spread into interstellar space and play a part in the formation of new stars and planetary systems. Thus, the study of Betelgeuse and similar stars helps astronomers comprehend the chemical enrichment of the galaxy and the mechanisms driving stellar evolution. The upcoming or recent supernova of Betelgeuse would mark a pivotal moment in this stellar life cycle. Researchers are particularly interested in the governing mechanisms for the transition from a massive star's final stages to its explosion. Current models suggest that as supergiant stars like Betelgeuse approach death, they go through a series of intricate processes, like the collapse of the core and the dispersal of outer layers. These stages are distinguished by significant mass loss, which can impact the star's brightness and variability. By observing Betelgeuse's changes, scientists can gain insights into these processes and refine their models of stellar evolution. Additionally, the historical documents of Betelgeuse's brightness variations and its documented color variations provide valuable clues about its past states. Ancient astronomers' observations, though limited by the technology of their time, have provided a baseline for comparing current data. The transformation from a yellow hue to a reddish-orange color over time possibly reflects the star's internal changes and its progression toward a supernova. This historical perspective improves our comprehension of how massive stars evolve and how their life cycles impact surrounding environments. The potential for Betelgeuse to become a supernova also intersects with our understanding of cosmic events on a larger scale. For instance, the study of supernovae helps astronomers investigate the conditions leading to different types of explosions, such as Type 1 and Type 2 supernovae. Type Y supernovae are typically the result of thermonuclear explosions in binary star systems, while Type 2 supernovae, like those expected from Betelgeuse, arise from the core collapse of massive stars. Comprehending the distinctions between these occurrences can assist researchers in piecing together the history of our galaxy and the frequency of such occurrences. Observational difficulties, like Betelgeuse's current position behind the Sun, emphasize the challenges involved in studying such dynamic celestial objects. Despite these challenges, astronomers use diverse methods for observing stars that are, for instance, temporarily obscured. Space-based observatories and advanced telescopes are used to track the star's light curves and spectral data. These methods provide crucial information about the star's composition, temperature, and potential for a supernova. In addition to these technical approaches, theoretical models play an important role in predicting and understanding supernova events. Scientists develop simulations that incorporate current observations, historical data, and theoretical physics to forecast how a star like Betelgeuse might behave. These models help in predicting the timing and characteristics of the supernova, offering insights into what observers might expect and how the explosion will impact the surrounding space. The implications of a supernova from Betelgeuse's capabilities go beyond astronomy. For instance, a supernova of this magnitude contributes to our familiarity with cosmic radiation and its effects on Earth. Despite Betelgeuse's distance ensuring that it poses no threat to our planet, the study of supernovae contributes to our knowledge of cosmic rays and their interaction with Earth's atmosphere. This information is essential for comprehending space weather and its potential impacts on satellite operations and communication systems. Finally, the potential discovery of Betelgeuse's supernova remains a source of excitement and intrigue within the scientific community. The event would not only advance our knowledge of stellar life cycles, but also captivate the public's imagination. The dramatic visual impact of such an explosion, visible for months or even years, would undoubtedly motivate a new generation of astronomers. The general public's interest in astronomical events often fuels outreach for education and promotes scientific literacy, emphasizing the importance of continued investment in space research and exploration. In conclusion, the potential supernova of Betelgeuse represents a significant milestone in our understanding of stellar evolution and cosmic events. The ongoing observations and theoretical work surrounding this star contribute to a deeper understanding of the universe's workings. As we await further data from the James Webb Space Telescope and other observatories, Betelgeuse continues to provide valuable perspectives on the dynamic processes governing massive stars and their ultimate fate. Whether Betelgeuse has already exploded or is close to this dramatic event, its story underscores the ever-evolving nature of our exploration of the universe and the never-ending search to uncover its mysteries.